Okay, this is Mr. Peterson again. We're going to finish off here with this fifth page of the review for 7.1 through 7.6 of Algebra 2. Specifically, problems 30 through 35. Okay, on problem 30, we're supposed to write this expression that comes at us in radical format in exponential format. So the first thing you should note is that the index here, because it's a cube root, the index is 3, and then you need to know that that always goes on the bottom of your rational exponent. So whatever the index number is goes underneath the other one. Okay, here's another example of that, but there's a little bit of a twist in here. Your 4 and your x, a lot of people think those are both underneath the fifth power. In this case, the 4 actually has a first power on it because there's no parentheses extending the base of that fifth power. So then when you put the index underneath each of these, you get a 1/3 power and a 5/3 power. Okay, example 32. We have a negative exponent, so we're going to take care of that by taking that downstairs. And now we have a positive exponent. And then the index here, because of the 4 on the bottom of that rational exponent or that fractional exponent, is going to give a 4th root of 16 to the 3rd power. Now 2 times 2 times 2 times 2 gives 16. So the 4th root of 16 is 2, and then you have to cube it, which gives 8. So our final answer here is 1/8. Okay, 3 more examples here. On the number 33 here, we have an exponent of negative 2/3 on that x, but then it's got another one stacked on it. Stacked exponents get multiplied, so you're going to take that negative 2/3 times 12, and then you get a negative 8 for your new exponent, which takes you downstairs with a positive 8 exponent. So 1 over x to the 8th power. Okay, on the next problem, you have side-by-side variables that are matching, x and x. They're multiplied, and in this context, you add your exponents. So you're going to take 1/3 plus 3/4. I'll show you how to do that in a minute here. It gives 13/12, and so then you just write it in radical format with the index of 12 on the outside. Okay, I'm going to go back to how to do the adding of those fractions. Besides doing it on a calculator, you can go 1 times 4 is 4, plus 3 times 3. So you start with the downhill and then go uphill. That would be 9. 4 and 9 adds up to the 13 that you have on the next line. And then you go across the bottom for your new denominator, 12. So it's downhill, uphill, across the bottom. And you multiply them, add the first two pair, so 1 times 4 plus 3 times 3 gives 13, and then you go across the bottom, 3 times 4 is 12. There's other ways to conquer that, but anyway, you add your exponents on that problem. Okay, the final problem on this section is number 35, and we don't have, like the previous problem, we don't have matching bases. So you see we had matching bases up there. We're not going to take the same approach. You can't add those exponents. So what you're going to do here is just consider that 8th power to be stacked on the other two. We'll be multiplying, first of all, negative 1/2 times 8, and then 3/4 times 8. Stacked exponents get multiplied. And because the x has a negative exponent on it, you're going to take it downstairs. And that does it for problem 35. So on to number 36 in the next video.